Okay, let's continue on thinking about how we're going to find the size of an angle when, for example, the tangent of an angle can be positive in both the first and the third quadrant. So now we're going to concentrate on something in the third quadrant. I've left the picture up here from the previous video because I want to start illustrating how this looks like a bow tie in the end. So I'm going to draw. Actually, I'm going to do this in black. I'm going to draw the rectangular coordinate system again, and we're going to look at a 5, 12, 13 right triangle. So for illustration purposes, I'm just going to, make it a different right triangle. So I'm going to go to the right 5, up 12 with a hypotenuse of 13. And I'm going to drop the reference line down to the x-axis to create the right triangle whose legs are 5 and 12. Again, right triangle. Hypotenuse is 13 by the Pythagorean theorem, and this is called my theta, my reference. A little hard to write this in here. That's supposed to say REF. I'm going to take that now into the third quadrant, and I'm going to go to the left 5 and down 12. And I'm going to try to draw the hypotenuse of a right triangle that looks just like the one I just drew. But now, instead, the legs are going to be a -5 and a -12. But remember, the hypotenuse is always a positive 13 because when you take these numbers and square them into the Pythagorean theorem, they'll become positive. And then you'll take the square root and you get that 13. I just would like you to notice again that this angle right here and that angle right there are the same size angles again. And so I want to go ahead and write the values for the sine, cosine, and tangent for the angle that's represented in the first quadrant. And so let's go ahead and write those with that 5, 12, 13. So remember, sine is y over r. So sine is 12 divided by 13. Cosine is x over r. And so that's going to be 5 over 13. And tangent is y divided by x. And so we have 12 over 5. So then we go and compare it to this angle that's bigger than 180 degrees. Would you please notice? Let me go ahead and take a red marker and just notice that I'm speaking now about an angle 180 plus this bit right here. 180 plus. That's the size of the angle I'm speaking about. But sine is still defined as y over r, and y in that quadrant is a -12 and r is at 13. Cosine is defined as x over r, and cosine is a -5 over that hypotenuse of 13, and tangent is defined again as y divided by x. And remember, because they're both negative, y is a -12 and x is a -5, that ratio is a positive 12/5, and we have already stated that we knew tangent was positive in the third quadrant. Sine and cosine were not. But here's the dilemma. Now, I could be pointing to anything kind of here, but I just want you to see that in the first quadrant and in the third quadrant, the value for these two different angles, totally different angles in terms of size, the value is the same. It's 12/5. So if you went and found that little reference angle, the acute angle, by going into your calculator and say, hey calculator, go second tan and put in the 12 divided by 5, it is only able to give you an angle of 67.4 degrees. It's not able to give you the size of this red angle, this one right here. It's not possible. So what you have to do is you have to think for a minute about taking that right there. I stopped right at the x-axis. What's that, 180? And add that to it. So to find the third quadrant angle, you have to take 180 degrees and add your reference angle of 67.4. So the other angle where this is true is a 247.4 degree angle. Finally, don't forget that you could check on your calculator and you could see if both the tangent of 67.4 degrees and the tangent of, I'm sorry, I shouldn't have an equal sign here. Try to get rid of that. the tangent of 67.4 and the tangent of 247.4, check and see if they're both about 12 over 5. And as a decimal number, 12 over 5 is 1.4, so or 2.4. See if those are both approximately 2.4. Then you know you found the correct angle. Let's go ahead now and do this again with an angle in the first quadrant and an angle in the fourth quadrant. So I'm going to draw in the rectangular coordinate system a 6, 8, 10. So I'm going to go to the right 6, up 8, and then draw the hypotenuse of 10. Drop the right perpendicular line to the x-axis so that I have a right angle, and then put in the leg of 6, the leg of 8, and the hypotenuse of 10. Again, remember that's called my reference angle. I want to compare that to an angle in the fourth quadrant. So I'm going to try this time to go to the right 6, down 8, and draw my hypotenuse. And I'm going to try to drop, this is going to be a little funny, not bad, I guess I'll leave it. There's my right angle. So in this reference right triangle in the fourth quadrant, I'd go to the right 6, I'd go down 8 on the y-axis, and the hypotenuse would still be 10. So again, as we have before, let's compare the ratios for the first quadrant. So sine, cosine, and tangent. Still just the first quadrant, because in that quadrant I'm finding my reference angle. So the sine is y divided by r. Again, yes, go ahead and reduce it, 4 over 5. Cosine is x over r. Yes, reduce that to 3 over 5. Tangent is y divided by x. Yes, reduce that to 4 over 3. Compare that now to the sine of an angle in the fourth quadrant, which is y divided by r. Well, my y value there is a -8, and my r value is 10. Cosine in the fourth quadrant is x over r, and my x value is 6, and my hypotenuse is 10. And then tangent in the fourth quadrant is y divided by x. My y value is a -8. My x value is 6. You know, again, look at these. First quadrant, everything's positive. Fourth quadrant, only cosine is positive. Sine and tangent are negative. I know they have these same ratios, but remember, just the sign has changed. What I want to do this time is I just want you to notice again that, oh my, cosine is positive. It's 6/10 in this particular angle in both the first and the fourth quadrant. So your calculator is only able to go and find that first quadrant angle. So if you go find what's called the reference angle by typing in second cosine of 6 divided by 10 or 3 divided by 5, you would get an angle for that of 53.1 degrees. My picture even kind of shows that this angle is a 53.1 degree angle. My calculator doesn't know how to find this 90, 180, 270, more than 270 degree angle. It does not know how to find that. And I have to help myself out by going all the way around this circle to 360 degrees, and then I've got to subtract this angle right here, which is 53 degrees in size. See that 53 right there? Those are congruent triangles. So this angle, the same because of these ratios. So in that fourth quadrant, I've got to, in order to find that angle, I've got to take 360 degrees and subtract the 53.1 to find that the other angle, whose ratio for cosine would be 6/10, by using that reference angle. So again, your check would be to take the cosine of your 53.1 degrees, take the cosine of 306.9 degrees, and see if they both turn out to be 6 over 10, or approximately 0.6 on your calculator when you type those in. Would you finally notice, again, one last time, here's the pictures that we've been creating. Every time in the rectangular coordinate system, I've been drawing a right triangle in this first quadrant. And I've been referring to this angle called the reference angle. When I went to the second quadrant, I went off over here like this. and was speaking about an angle between 90 and 180 degrees. But to get the size of that angle, I went to 180 and subtracted the reference angle. So I'm going to fill in right here in the second quadrant. I went 180 minus the reference angle to find the size. In the third quadrant, I drew that right triangle again off that x-axis, and this time I went 180 and added this reference angle. So in the third quadrant, again, 180 degrees plus the reference angle. And finally, the thing we just did lastly in the fourth quadrant, and I'm creating a bow tie, or attempting to create a bow tie. I wish this would turn out nicely. And in that fourth quadrant, we went all the way around the circle to 360 and subtracted the reference angle to find the size of the angle. And I can use this table, this chart now, given that the values of the trig functions are positive in two locations and negative in two locations. I can use this idea by always finding the first quadrant angle, which is the reference angle, and referring to these statements to complete my work.